Probably I can start the introduction part first.
Okay, sure. All right, go ahead, Diana.
Okay, thank you, Mr. Pham. Okay.
Yeah, sure.
Hi, good morning, everyone. Welcome back to Virtual Oscilloscope Teacher Training. I'm Diana. And as last week, we already learned about the basic theory of wave and also the basic theory of oscilloscope and also how to use decimal calculator application. And this week, teacher will learn and explore more about how to use the oscilloscope simulator by using Multisim. Do all teachers already sign up for the Multisim? If not, it's okay. Because I will show step by step how to sign in, how to sign up, and also the create account for the Multisim. And good morning once again. I'm Diana from Penang Science Cluster. Before we begin our class, there are several class rules that I would like to tell. First and foremost, please keep your phone in silent mode. And the second one, if you have any question, you can send via the Q&A below your laptop. Where if you can't see it, that means you are in full screen mode. You can press the ESC or the escape button on your laptop, and then you can see the Q&A box and below your screen. And then the third one is the most important part, which is for JPNPP report purpose. Please take two photos of yourself during the training, which means you can either take a selfie or you during the training session, or you can ask for your friends to take the picture of yours during the training session. Because these two photos you will upload during in the Google form, which I will share with you at the end of the session of this training. Saya akan ulang sekali lagi. Sila pastikan guru-guru mengambil 2 keping gambar. Sama ada guru-guru boleh ambil secara selfie yang ada guru dan juga laptop, ataupun guru-guru boleh minta rakan guru-guru ambil gambar guru bersama laptop sepanjang sesi training ini. Kerana guru-guru akan upload 2 gambar tersebut di dalam satu Google Form yang akan saya berikan linknya pada akhir session ini. Saya harap guru-guru boleh take note benda ni sebab pada minggu lepas Miss Amirah bagi tahu banyak gambar yang hanya menunjukkan laptop sahaja, iaitu skrin laptop sahaja. Kami memerlukan gambar yang ada cikgu sekali termasuk dalam gambar tersebut. Saya harap cikgu boleh take note untuk minggu ini ya. Ya, itu sahaja untuk bahagian ini. Cikgu-cikgu boleh dapat ke? All of teachers can get it? Is it clear? Because this part is very important because it's for the JPNPP report purpose. Cikgu boleh dapat ke kalau cikgu clear? Clear? Okay, terima kasih. I will move to the next slide. Okay, do all teachers already sign up and sign up for the Multisim live? Because I need the response. If not, I will teach step by step how to create the account for the Multisim. I share with you once again the link for the Multisim live link. When you open the Multisim, done. Okay, any other teachers? Any other teachers or not the sign up yet? Okay. When you open the link, I will show step by step once again. Okay, already log in. Okay, I just show once again lah. First, sign up and then fill in the information and create account. Okay. See, already log in. Do any teachers not log in yet or not sign up yet? Because if you're not signed up yet, I will give you few minutes for you to sign up and create this account first. Do any teachers not sign up yet? Not sign up yet. Okay. I explain once again. Okay, I already shared the link. First, open this link, themultisim.com. and then you will see the first page of the Multisim. And then you can see the sign up here, and then click on the sign up, and then you fill in the information. Once you finish fill up the information, you can click on the create account. I will give around 2 to 3 minutes for teachers to sign up for a while. Okay, I hope all teachers already completed the sign up completed the sign up. Okay, make sure you prepare this thing before we begin our class. First and foremost, the strong internet connection. The second one, your own laptop. And the third one, of course, is pen and notebook for you to take note for today's class. As for the next one, is the Google Classroom class code. Uh, I'm pretty sure that all teachers already in the Google Classroom. But if there's any new teachers, you can put this class code in the Google Classroom and join the Google Classroom. And please make sure, not please make sure, the all teachers in this class, in the Google Classroom, we already provided a few of quizzes and also assignments for teachers to do to keep practicing about Desmos calculator and Multisim calculator. I hope all teachers can answer all the assignments given inside the Google Classroom for you to understand better about Desmos calculator and also Multisim. Kepada guru-guru yang sudah ada dalam Google Classroom Oscilloscope Class, guru-guru bolehlah menjawab semua assignment yang telah diberikan kepada guru-guru kerana assignment ini untuk guru-guru lebih memahami berkenaan pelajaran yang guru-guru telah pelajari sewaktu minggu ini dan juga minggu lepas. Okay, sekian sahaja. That's all for me. I will pass to our trainer to continue our oscilloscope class.
Okay, thank you, Diana, for the
Okay.
introduction.
Okay.
And thank you all for spending your busy time with this training. I know you guys are very busy, and teacher's job is never done. Okay, I know because I was a lecturer then, and a lot of job. So anyway, thank you for spending this time. Thank you for also for doing the exercises. I'm very glad that most of you did well. And just want to review some of the points in this last week. Okay, I cannot share. Is there a way, Diana, I can share my screen? Okay, hold on a while. Okay, I need to share. Okay,
Okay.
okay. I think let's see. Everybody can see my screen? Yes. Okay, good. So on the non-sinusoidal wave, you have this equation here. It can be shown that the non-sinusoidal wave can actually consist of many sine waves combined together. This is actually the Fourier series. Okay, I think some of you put harmonic series. Actually, they're quite close, but this is the actual equation that describes the waves that combine together into different expressions. So for the Fourier series, the an and bn are coefficients which can be any value. So different values will determine what type of shape. And also a0 is actually the dc value. So it's just like y equals to mc, this is like the c. So you change this a0, it will shift the waveform up or down. Okay. Uh, I hope you enjoy the Desmos calculator. I hope you find it useful. And I see one of you also use the Desmos calculator on the handphone. Actually, very challenging to use the Desmos calculator on the handphone. I tried it. It's actually quite small, but one of you managed to do it. Congratulations. Okay, so today, if you have any questions for last week's lesson, please just put in the Q&A or the chat. Okay, let me put in the Q&A. Let me open up my Q&A. Let me get out from here. Okay, I need to put my Q&A up. I got a chat Q&A. Okay, I got two windows open. Okay, let me share.
Mr. Pham,
Yeah.
can I change your role for co-host for a while?
Pardon?
I changed your role for become a co-host for a while. Is it okay?
Sure. Okay, sure. So I don't do anything. Okay.
Okay. Okay, done. Okay, done, Mr. Pham.
Okay. Yeah, sure.
Okay.
Okay, let me share my screen here. Okay. So today we are going to do more demo and more hands-on rather than theory. So we are going to do analyzing of the waveform. We're going to first of all have some theory on what is the period, how you measure period, how you measure frequency, how you measure the peak voltage of a sine wave or a square wave. And going to do a demo for the oscilloscope, the live demo. And also we're going to introduce you a new tool called Multisim Live. It's free also, except that the free version, you don't have many circuits that you can put here, but this is very useful for those of you who are teaching electronics. You can put in LEDs or buzzers or light in your circuit. You can test out the circuit whether it's functional or not before you put on the breadboard. So today is more of a demo and more question and answers, less of the theory. So first of all, okay, let me move this one away here. Okay, so the period actually is a cycle that repeat itself. Like let me go through the annotation here. So from one point here to another point here, okay, it repeat itself. All right, so either from here to here, you will repeat itself. Okay, so this is the called one cycle or one period. So for the for you to measure the one period on the scope, if you try to measure from here to here, it is not so convenient because it is sloping down here, and you cannot tell the difference between whether it's here or here. So normally what we do is we will measure the period, the top point here, which is very distinct, yeah, top point here to the top point here. That means this is one period, or the bottom point here to the bottom point here. So this is more accurate to determine one period on the scope. Let me take away this annotation. So for just now was an example of the sine wave. Now it is a square wave. For the square wave, since the top here is actually quite flat. Okay, let me share this annotation here. So it's quite flat, so you don't know where is the peak. The peak can be anywhere here. So normally what we do is we'll do the rising edge from here to here. We call this the rising edge. Okay, from the waveform goes down here. We call this the falling edge. So for a digital waveform, we will use the rising edge, the first one rising edge, and the next rising edge. So that means from here to here, this is called one period. All right, or you also can measure from the falling edge. This is from the falling edge here to another falling edge here. Okay, from here to here, this is also one period, or from here to here, it's also one period. So this is how you distinctly measure a period for sine wave and a square wave. Let me clear this drawing. All right, so another term that we normally use for digital waveform is called duty cycle. Duty cycle is defined as the period of when it is turned on. Let me put the annotation here. Okay, it is the duty cycle is defined as the time when the pulse turn on, which is the top part here, turn on. Over the period. The period is one cycle from here to here, or from here or here to here. All right. So the period is also actually the turn on cycle and also the turn off cycle. So this is called the duty cycle. So for some electronics, the duty cycle is very important because it will determine the performance of circuits, especially switching regulators and stuff like that. So just keep in mind on this theory. So let me go to the next one. Clear. Another important parameter for a waveform is we call this phase shift. In the previous exercise, in we saw that the phi is the shift between one waveform to another waveform. Let me annotate this guy. So now you see these are three waveforms. If they are very close together, you can see that some waveform are earlier, then this is the time. This is the time t, t, and then goes on. This is the later time. So you can see here what we mean by lagging and leading is this definition. If you see the pink waveform here, and this is the yellow waveform. So actually the pink waveform comes later because the time is later. So we will say that this yellow is leading. Yellow is leading the pink or ahead because pink come later. So, or you can say that the pink is lagging the yellow. So yellow is ahead or leading the pink, or pink is lagging the yellow. By definition of this axis, this is time starting count. So the pink one comes later. So in this example too, referring to the pink again, so the orange actually came later than the pink. So we call this orange is lagging the pink waveform. Okay, we go to the next one. All right, so peak to peak voltage, these are the definition for peak to peak voltage. Let me get the notation again. So normally in electronics, we will define peak to peak as the highest peak minus the lowest peak. So we call this V peak peak. Half of it is the symmetry, then half of it will be peak to the center. So this is called V peak. So these are the definitions for the sine wave. Another for the waveform, all the waveform have DC value. So the DC value will shift the waveform up or down depending on the value of the DC bias. Let me share. So in the orange waveform, it is actually centered at 0. That means you oscillate up and down around the 0. You balance on the 0. But some waveform like the pink one, it is up 1 volt. It is cycling or alternating at the 1 volt. So we say that this pink waveform has a offset, DC offset of 1 volt. And you see the yellow one actually is pushed down. Actually, so this is oscillating at the -1. So we say that this yellow waveform has a DC offset of 1 volt. All right. So any question so far before I go to the demo? None. Okay. So I thank you for the survey from the last week posting, and I noticed that most of you have oscilloscope in your school. So I will change the sequence of the demo. I will demo the oscilloscope first. The oscilloscope I'm going to demo is the digital scope. It's very similar to the analog scope with some features which are not available in the analog scope, but the function is the same. All right. So in this case, let me switch my stop sharing and switch my screen. I have another camera. Let me switch to another camera. Let me switch to another camera here. Okay, so you can see the picture of the oscilloscope. Now, let me switch on the oscilloscope here. So this is the oscilloscope that I borrowed from the PSC. It is 2 channels. Let me put the here. It is I think I need to mirror. Let's see, how do I mirror this? Terbalik, setting 0.
Mr. Pham, I can the screen tak terbalik for us.
The what?
The screen tak terbalik for us. Kami nampak yang tak mirror punya.
Oh, tak mirror ah? Oh, I see mirror. Okay, so now if I see here, is a mirror or no mirror?
Tak mirror.
Tak mirror, Okay. Good. So let me get this out first. Okay, let me get this out here. Let me end the show. Let me. Okay, give me a minute a bit kelam kabut here.
Tak apa, Mr. Pham, take your time.
Yeah, I cannot find my other screen. I got ada. Okay. So on your side, you don't see terbalik, is it?
Ya,
okay.
tak terbalik.
Because I see terbalik for my okay, never mind. So over here, we have like channel number 1 and channel number 2. So this is the 2-channel scope. Huh? So what I'm going to do is I'm going to give you a demo of this using this electronic board here. This is the electronic board that I use. There are many signals that we can actually detect or test using this scope. So this is the square wave, and this is the sine wave, etc. Okay. So let me get my thing here. Okay, in case you're wondering my setup, I just show you my setup. This is my second screen. This is my first screen. This is the microphone that I used last week. Looks like it's not very effective. So a bit complicated, a lot of wires for a while. So for this one, you can see on the scope, you just remember a few things on the scope. Before that, maybe I'll just give you, I'll skip to the theory first of the scope. Give me a while here. Okay, let me share my screen a bit here. Share screen number 1 and say PowerPoint here. So this model is DSO1152B. It's from Keysight. And actually, on the label for this product, it says Agilent. Actually, before Keysight was Agilent. So on this one, first of all, you need to look into, you see there are so many buttons here, but don't worry. You just need to remember four areas, 4 things. First of all, this top here, this is the time scale. These 2 knobs here will adjust the time. So some of your scope may be different position, but for this scope, it is on top here. There are 2 knobs here. This is for time. This is one section for the time. And this section is to change the voltage. The big knob and the small, I'll show you what this do. So this will actually change the voltage scale. Then the third one, these are the signal input here. The fourth one, these are the trigger. I will talk about trigger more because last week we realized that trigger is very important. I'll talk about more about that trigger. And next one, actually, these are actually extras for the digital scope. Like actually, it can measure frequency for you, or the period for you, or the certain functions which maybe some of the analog scope may not have. So another thing that is important is the probe compensation. Every time you use your scope with a new probe or different probe, you need to compensate or calibrate. If you don't calibrate, the value of the amplitude may not be correct. All right, so first of all is the compensation. We need to, on the scope here, we have a small screw knob here that we can actually use it to tune. If let's say your scope probe is tuned correctly, then it is flat and straight. If it's not compensated properly or not calibrated properly, you'll see that you skew up or actually skew down. So we'll do the calibration later. And okay, I'm going to go to the demo. So let's go in here. At least you got some theory. Let me share. Let me stop sharing. Let me share my screen. Okay, so you can see the scope. Without sharing, you can see the screen already, right? All right.
Yes, Mr. Pham.
You can, because for this probe, there are 2 probes that are provided. And actually, because there are too many probes around, Keysight, they actually have the color band. Like this one is the green color band. Green color band, if you attach to the green channel here, channel number 2, so whatever you probe here will be displayed on the green channel. And there's another one, This is the yellow channel band. In fact, this band you can actually change it. You can actually change it, and you can actually replace it another color like red or yellow or blue, etc., depending on the channel color. So in this case, this is yellow. So this is assigned for this yellow. So we just use one scope first. So what we do is we will do the compensation now. We will just plug into this plug here. Okay, once it's plugged in here, the probe will be connected to the compensation. On this side here, there's a compensation pattern. This is square wave. So you can see that it is not really compensated properly. So what we do is we will just move this up a bit, and inside this toolbox there is the something like a screwdriver. Okay, a small plastic screwdriver, or you can actually use your own screwdriver at home. And what we do is we will actually use this to adjust over here. That's the tuning port here. When you turn the port correctly, you can see that it will be compensated properly. You will compensate properly. Okay. Once it's compensated properly, then we can use the head and do the measurement. On the camera, maybe let's see whether it's quite flat. Okay, maybe you can adjust, but I don't have to spend so much time doing it. Okay, so this is just good enough. Then I can also use the other probe. Since I'm going to do the measurement using the other probe, we can connect to another probe here. I can okay, we have to on the second channel. You say the second channel. You can see that this is quite not well compensated. I can remove the channel number one. You can see, I'll do a trigger for you later. So now the thing is, I'll talk about triggering later. So let's say your signal is not triggered properly, you will be the waveform will be moving randomly. But if you put the trigger level correctly, once the waveform detects that voltage here, then it will be steady. Then you can actually do a calibration on your probe. Okay, so this is the way to do the probe compensation. So let me remove from here, and I just use maybe the yellow channel first. So this is the evaluation board that I'm going to use to demo some of the waveform. Okay, you can actually do your own project on using Arduino that can generate different waveform. So let me put in the battery. Okay, and when I turn on the signal, you will see different waveform. So I'll just ground one of them, and then I'll just take the first one. The first waveform is not very clear on the scope here, but one of the advantage of the digital scope is we have this button here. We call this auto scale. So when you press the auto scale, automatically it will try to think what type of waveform is available, and it will show it on the screen. So let me remove the green one here. So if I just open up this pen here, let me trigger the menu. Okay, give me a while. to explain the trigger later. Okay. So you can see this is the square wave, the square wave. And if you want to change the time, this is the time scale. You can actually change the time to be a short, longer time. Okay. Or you can zoom in. You can say zoom in, or you can zoom out. All right. And actually, on the other knob, this is to shift left. All right. Sometimes the waveform can be very far away. You can actually shift left or right. And on the this knob here, these two knob is for the voltage scale. So we can actually move the scale, or you can zoom up, increase or magnify. You can magnify or you can reduce your voltage scale here. And this one, the other button will actually reduce, lower down, or increase. Sometimes some waveform, it may be down here. You cannot see properly. So what you do is you need to adjust the level so that you can see on the screen. All the knobs here actually to make it more visible on the screen for you. Because maybe this is too small, you can make it bigger. Maybe the time here you want to have to see one period, so you can actually adjust it accordingly. So this time, this knobs are for time. These knobs are for voltage. So the other one is on the sine wave. Okay, actually, before that, there are many things on the scope here. Need to explain. You can actually do measurement on the scope using the cursor. For example, if I put in the cursor, I just put here manual, means that when I put manual means that I want to manually change the cursor position according to my own intention. So if I actually put the cursor, I can actually change the cursor to measure from position number 1. Cursor, we call this cursor A. And then I can change it when I press the button. I can change the position. And this actually is 1 period. So from here, if you can see the reading properly, it's not very clear, but you can see if I focus, let's see, let me try to focus. Let me try to focus. This is supposed to be autofocus. Okay, anyway, you can see that the cursor A and cursor B. So you tell you the delta of between cursor A and cursor B is 1.84 microsecond. So you can calculate for you 1 over delta x, which is the frequency also. So we're using the cursor, we can actually measure the period and you can calculate the frequency for you. Then on the other cursor, you can actually change the cursor instead of a time. Now we can change it to amplitude. That means I can actually move the cursor A here and to another cursor. Sorry, another cursor here. So it will show you cursor A is 2 volt, cursor B is minus 1.92. So the delta of the cursor is actually 3.92, okay, depending on the position of A and B. Yeah? So this is the peak to peak of the waveform. All right. So let me talk. So this is the cursor function. Another function that for the digital scope you can use is the measure function. You can press measure and you can measure, let's say, the time here. Let's say I want to measure the frequency. If I can measure the frequency, I just click one time. It will display for me the measurement. And I can actually say that I want to measure the period. I click here, the period will be shown for me also. I can also measure voltage. What is the peak to peak voltage here? it will also show me the peak-to-peak voltage is 3.84 volt. So this is the one of the important parameters or the important buttons that we use to do measurement, and we would use this buttons here for this purpose. So let me actually go to the another waveform.
Mr. Pam,
Yeah.
God teacher asked, when use oscilloscope, must use both channel or one channel?
One channel depends on your application. If you only got one signal to analyze, then one channel will do. But if you got the two signals to analyze, then you need two channels. If let's say you have four signals to analyze, then it depends on the application. I will show you with two channels afterward. Okay. So if you have a need for four channels, then four channels need to be opened up for your evaluation. All right. So for this one, let me put in the sine wave here. So one thing good about this scope is that when you press auto scale, you will automatically find the signal for you. You can see, actually I don't want the green one, I disable. So it automatically finds that's a sine wave for me. Okay, so if the waveform here, let me remove all the measurement. The waveform here is not stable because it doesn't know when to stabilize. So this trigger button here, this trigger here, actually will tell the scope that if let's say the waveform reaches this value, okay, let me change this. So there are two channels here. We need to select the correct source. So source number one is the yellow, source number two is the green. So we have to change this to channel number one. So it will be stable. So if the trigger level is not correct, then it won't be stable. The trigger level here will tell the scope to, if you get a waveform which is cutting across this line here, then please stop. It will stop for you. So in this case, we have the sine wave, and we can do the various measurements like peak to peak and period, etc. for yourself. Okay, let's say this is the do the time here, the period. So you can see it will show the period. You will show the you can see here, right? So this is a simple demo. So if I can actually put another probe here, I on another probe here. Let me go back to the square wave. This is the okay, let me go back. Sorry, the sign here. There are too many buttons here. Okay, so you can see that actually the green and the yellow channels are up. Let me remove this green here. So the difference between the yellow and green here is that the phase are different. So at the moment the phase are same. The phase of the yellow and the green one is the same. There's no leading or lagging. But I can actually adjust a knob on my board here, and I can shift it, this one, okay, to be later. So the yellow one came first, and then the green one comes later, because this is a time axis. So I can change my phase here using the knob here. So this is the phase difference between channel 1 and channel 2. All right. So one of the common experiment people do in physics is to understand the phase between channel 1 and channel 2. On the horizontal scale here, we have this base, time base. Instead of amplitude versus time, we can change this to amplitude versus amplitude of x versus amplitude of y. So you can see a very interesting image here. So if you can see, this is the straight line. That means the phase of the two waves are the same. If I change the phase here, you can see that it will change. Okay, so this is almost 180 degrees out of phase, and this is 90 degrees phase difference. So I change my horizontal to y to t. Okay, you can see that actually it is 90 degrees off. All right, so this is the short demo of the scope. Okay, another thing I want to point out is the trigger. Let me go into this yellow waveform here. And I point to, let's see, one of this here. Okay, let me remove this screen. So now the thing is, for this waveform, it triggers by a button here. This is a button here. Okay, it's not very clear. So it triggered by a button here. So if I press a button here, the signal only will come up one time. Okay, if I don't press a button, there's no signal. So the way to capture this signal is we need to use a trigger function. So first of all is we need to put a single trigger. Okay, a single trigger. A single trigger means that when you catch the waveform, just display it on the screen and don't capture anymore. So the second thing we need to do is we need to make sure that the trigger level is correct. Let's say I put the trigger level here, it's correct. Since this is a digital board, I put at the halfway for 2 volts here. So if I put the single trigger here, it will not capture anything unless I press the button. If I press the button over here, the signal will be captured. Okay, and it will change from single to stop. Then the signal in the digital storage scope, you can actually zoom in and zoom out and see for yourself under the zoom pattern here. So if I do a single again, it will not show anything unless I press the button that there is a trigger, a signal coming at this time. When I press, it is waiting. The scope is saying that it is waiting for a signal. When I press the button here, it will capture all the time for me, right? So this is the purpose of the triggering under the trigger signal here. And also depending on your trigger menu, whether it's going to be H trigger means that once you detect this H here, please stop the waveform. Okay, so this is the important portion about the trigger. All right, so I've described to you the horizontal function, the time, and this is the voltage, and this is the trigger menu. Okay, this button here is not a channel. This is for a signal to actually go into the scope to trigger a certain waveform. So this actually 2 channels. This is not a channel, and these are the cursor. You can press the cursor to measure. Let's say if I want to do a measurement on the width of the pulse, I just change the type to a time, and you can see, where is it? Coming soon. Okay, give me a minute here. Get out. Okay, for some reason, I think it doesn't work in this mode here. So you can actually use the, by right, it should, I can measure channel 1, voltage, peak to peak, peak to peak. Okay, it will measure for you. So in the same way, the cursor, we should be able to do it. Let's try one more time. Source, okay, the source is channel 1. It's a green, it's a yellow. Just now I was in the green. So, and I can actually use this position here. This position number 1 minus position number 2. The delta will be 76 microsecond, and 1 over the delta x will be 13.2 kilohertz. All right, so this is the measurement. This for measurement, and this is I think there are a lot of buttons on the scope here, but don't have to worry. For your purpose in your lab, you just have to just understand what this horizontal time or this button do. This one controls the time. This one controls the voltage. This is the trigger. Okay, trigger the pulse, trigger level pulse, and these are the cursor. You can actually use the cursor to move to do your own measurement. And these are some measurement button on the digital scope. I'm not sure whether the analog scope may not have the measure function, but the digital scope has this. And the one of the feature for the digital scope is this auto scale. When you press auto scale, it will detect a certain waveform for you. For example, in this case, this is one waveform, which I just press the auto scale. It will detect for me that the channel 2 got nothing. Okay, and channel 1, this is the so-called staircase. You need to do the trigger, source, change the source to, all right. So this is the staircase waveform. All right, there are a lot of things to be demoed here. I hope I'm not confusing you. So basically, it's just keep in mind the 4 areas: the time, the voltage, the trigger, and the cursor area. All right. Okay. Wow, a lot of things to learn from here. Anybody got any question? Okay. So in case that you don't have this type of board, let me show you also another trick. You can also use your handphone. Your handphone has an app. Give me a while here. Okay, it is a function generator app, which actually you can use a wire, a normal stereo wire. We can actually plug in to your handphone through the speaker or the earpiece, and you can actually use the other end of the wire. You can actually clip to this, let's say the yellow one. First one, this is to the ground. Let me clip the other one first. This is to the ground. The first pin here, or the one that is nearest is the ground. Then the second one is the one of the channel here, and that's another. All right, okay. So I can actually use this guy to generate the signal. So I just do auto scale. Okay, so you can see that my handphone has an app to generate the sine wave. This is the FM signal. Let me remove that FM. Okay, so I can change my the frequency of one of the channel. I can enter value, let's say to 2K. The frequency will change to 2 kilohertz. I can also change my phase information. Let's say if my frequency channel 1 is 2K, my channel 2 I can change to 2K. Okay, so now we have two signals here. I can change one of the phase to you can see one of the yellow one is shifting up and down. Okay, so actually if you don't have the board such as this, you can actually use this app on the handphone. You can change it to a triangle wave, or a square wave. But the square wave doesn't look so nice on this handphone. Let me change this phase frequency. Let me change it to maybe a lower value. Okay, so it not very nice square wave. So, but I think for demo purpose, this is quite useful for a quick demo. All right, let me off this guy here.
Mr. Firm,
Yeah.
I got question. Can you show how to measure the battery voltage and also how to connect the battery?
Oh, I see. Battery, most of your phones now, battery are inside your phone. But fortunately, my phone here, let's see if I can open up my phone. Well, this is a special request. Let's see if I pick up my phone here. You can actually, there are three terminals to your phone here. I think, let me see, I need to off my phone here. Actually, if you give me a little time, I will I have a spare battery in my cupboard. So in the, okay, let me switch here to the camera. Okay, so if you actually, on the battery, there are three terminals. One or AA battery. Okay. Okay, give me a few minutes later during the break time. Let me get the battery, and then after that, I'll show you how to do it. All right. Okay. So anyway, thanks for the question. And I know there are a lot of information today. But the important thing is that we need to practice. Once you practice, then you are very comfortable with all these settings. So any questions so far? Okay, if not, I'll go to the next session on the multi-sim. Okay, Diana, you want to take a break? 5 minutes?
Okay.
Can, the 5 minutes. Let me get a battery.
Okay, Mr. Farm.
Yeah, sure.
Guru, terdapat satu QR code. Sebentar, saya akan share. Okay. Sementara guru-guru sedang berehat, guru-guru boleh scan QR code tersebut dan guru-guru boleh jawab fill in lah post survey untuk sesi kedua oscilloscope kelas ni. Kalau guru-guru tak boleh masuk, tolong beritahu saya boleh hantar link di bahagian ruangan chat. Terima kasih.
Okay, I think I can start already lah. Okay, I got this couple of batteries here. You can use multimeter to measure. On the scope also you can measure. Let's see on this scope here. So once you got many scope probe on your bench, you cannot tell which scope goes to what channel. So the color band is very useful for us to determine what channel goes to what probe. So I have the battery here. It's a 9-volt battery. you can actually use this under this. This is the yellow. Okay. So first of all, is for measurement of DC or AC. You want to measure DC value, we have to change it to DC coupling. All right. So you have a DC coupling. Let me remove this number 2. You can actually measure DC. So making sure that your voltage scale is correct. So over here, channel 1 is 10 volts per box. You can show here 10 volts per box. I can change it to 5 volts. So if I put in the battery here, I measure. So this voltage here actually went up. Alright, so it went up and you can actually measure one box. So from here, one box is 5 volts, 2 box is 10 volts. Actually, this is a 9 volts battery. You can actually use this one to measure, see whether it can measure the voltage for you. I think this maybe max. See what it says here. Okay, it says here 10 volts, but actually it's 9 point something volts. Could be close to 10 volts. Okay, or you have another battery, which is the normal AA battery. You just put one as a negative here. Unfortunately, we cannot clip. Another one at this point here. So you can see the voltage is shown here as 2 volts. It's not so accurate, the scope, unless you can change your scale. Is 1 point. If you change your scale too small, then it may not measure for you. You have to change it. You have to magnify the amplitude. Then you can see this is about 1.52, 1.6. You actually amplify it further. See, about 1.68. Amplify further. Okay, about 1.62. Okay, so this you can actually use the scope to measure your battery this way. Okay, let me go to another screen here. Right. Okay, so I think that's another question here. What app is installed in the phone that provides signal to the scope? Okay, I will send to you later. Because I also forgot what app I have installed on my phone. I'll send to you later. Right. So on this one, I'm going to give you a demo on the Multisim Live. So let me share my screen here. If you have an account with the Multisim, okay, this is how it looks like. Okay, so what you do is, let's say that we want to do some simple circuit. Give me a while here. Let me change my screen a bit. Okay, so what you do is you create under the circuit here. Let's see. Okay, sorry, this button here. Under this button here, let me do this button here. You create the circuit, and then a blank page will turn up. So this is online. You need to have internet all the time. So let me describe the interface for you. First of all, is the first one here. Okay, interactive. Let me describe later. On this portion here, this is the schematic where you can draw your circuit. And this is the graph. It will show you the response of the graph. It's nothing yet because we have not drawn the circuit. And you want to have a view both of schematic and the graph. You can click this one. So graph and the schematic will be shown at the same time. Okay, let's go to the schematic. And under the schematic, on your left-hand side, the number of buttons you can use, like for example, these are ground function. This is the source. You got the AC source, DC voltage, and a lot of functions here we can click. Later I'll show you some of them. these are the passive, like the resistor, capacitor, inductor, and this is the op amp, etc. And this is the diode, including LED. It's the transistor, the lamp, switches, a lot to explore. So if you're teaching like electronics, this is very useful to actually show the children the circuit. And also some exercises in electronic book, you can actually draw the circuit and verify the performance yourself. So let me start by doing a simple circuit. Okay, like if I can actually use this light here, that's a lamp. I'll just click, when I click once, the picture will show. Okay, and your mouse, it will move together with your mouse. And when you click to place it on the schematic, there are functions here, like these are the, to rotate. You can rotate it, okay? Or you can actually flip it, or you can duplicate another one, or you can actually remove. So this is a lamp. And another thing we need to do is we need to put, okay, before that, there's a gear here on the gearbox. Let me put in the annotation. That's the gearbox here. That will show you the other options. Like over here, it tell you that you click on this, the lamp here, it tell you that the voltage is 12 volts maximum. If you put 15 volts, it will blow. Okay, so let's try to put in the voltage here. I put in the DC voltage here and put it next to it, place it here. I place another one, which is the ground, and I place it here. Once you place everything already, you need to wire up the circuit. So to wire up the circuit, you just have to move your mouse to a point here. Then you can see like a thread, They actually move the thread, okay, from here to another point. Okay, what you do is you click once, and then move to another point to the battery, and then you release. You click once, and then after that, you release. So now you have a simple circuit already done. So what you do is, to run the circuit, you need to press this button. There's a play button here. There's a play button here, and there's a stop button here. So when you actually run, so now the voltage, to determine the value for this voltage, you just do a click here. You can see this is 12 volts. Or you can actually do a right click on the value here. This is 12 volts. You do a right click. Okay, you do a left click. You do a left click on the value. You will come out with a slider. Right? So if I run the circuit here, let me zoom up for you. If I run the circuit here, the lamp will light up. All right. So if I increase my voltage, if I change my slider, I move the slider to 17 volts, the light blow already. Yeah. Okay, it's telling you that the voltage too high. If I adjust it to maybe smaller value, 11 volts, I run again. I need to stop. I need to run again. The light will light up again. So I can change my voltage here to low voltage. You can see that it's not so bright anymore. The yellow is not so bright. So maybe 0 volts, the light don't light up already. Okay. So let me put it brighter. You can see that it's about this voltage. You can see it's yellow. And if I can put it okay, I think you can click this higher to 12 volts. You can see the filament become red already. And then you put in higher some more. You'll be point where it's 15 volts. 15 volts, above 15 volts, you will blow. Okay, let's see here, you will blow. Okay. So this is a simple circuit. Once you run, you can actually stop here. Go to schematic. I show you the another circuit here, which is the LED. You can use the LED, put it here. Let's say I don't want this one, and I want to put the resistor here. Resistor point here. I can move this LED closer to the circuit here. Then I can wire up. I can put the wire here, 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 here. Okay. So now the voltage here, we don't need so high. So maybe we change it to maybe 5 volts will do. And then resistor, namely is about 200, about 200 ohms. So once I actually turn the play button, so you can see the LED light up already. Okay. So you can actually do many circuits with this to verify your circuit whether working before you make a breadboard. Yeah. Another thing is I can do is I can put in one more example of a buzzer. I click a buzzer here. Here. Let's say I don't want the LEDs. I take away this one. And let me take away this resistor also. And I connect this buzzer here, buzzer here. So now if I click on the property of this buzzer, it's telling me that the voltage is 9 volts and the frequency is 200 hertz. Okay, so when you do this simulation, please turn your volume low because you go to your ear, the audio will come to your ear. So if I change my voltage here to 9 volts, 9 volts, about 9 volts here. And then when I turn on the circuit, okay, let me turn the volume lower. Okay, the buzzer will turn on. Okay. I can change the frequency of the buzzer by clicking here. Okay, the buzzer frequency can change. This is good for your ear to test. Okay. Okay, so you can mix sound, the circuit can mix sound on the speaker. Then you can actually test your circuit. All right, so this is a quick demo for the multisim. So any questions so far? Okay, okay, let me go into this create circuit. I'm going to create a circuit using this as an AC waveform. So what I do is instead of a DC, I'll put in the AC, put in the AC source under AC voltage. AC voltage, that's like here. Let me remove this one and this one. And the ground, I want the ground back. And I can put in a resistor of this component, and I can rotate it. Then I put a wire. I wire this here, and I wire this here, and I wire to the ground. So now we have a simple circuit setup already. So if I actually run the simulation, let me clear the annotation. Annotate clear. So if I run the simulation, okay, I need to take out this. If I run the simulation, it is running. Okay, sorry. I need to give me a warning. You need to connect a probe. You need to tell the multisim what you want to measure. I want to measure the voltage here. Okay. So now I can actually place the play button. When I press the play button, it is running. But I don't see anything because I need to show the graph. Then you have to click into the graph mode. The graph mode will show you there's a sine wave being generated. And you can actually do a split. You can actually view the schematic and the sine wave at the same time. So this is how you generate the sine wave. Let's say that you have already generated the sine wave. You can actually stop. You can stop this waveform. All right. So this is a simple circuit to generate the sine wave, and this is the interface. If you click on the graph here, once you see the double arrow, you see the double arrow on my screen, my mouse become double arrow. I can scroll the wheel, the mouse wheel. It can change. It's just like your scope. I can change my time, whether zoom in or zoom out. Okay, and when I press the button, the left button, I can move left or right, just like the scope. So I can magnify or zoom out, and I can shift. And on the amplitude, same thing also. I can shift using the mouse. Click on the mouse, and then you can shift up, or you can use a wheel. The wheel will actually magnify in or magnify out. Okay, so it's like the interface that you see on the scope just now. Okay, so now if you want to analyze this waveform, I can actually measure the period by using this cursor here. If I click on this component, the tool will tell me here. The tool will tell me this is component. And if I click on the graph, these are the settings on the graph. I will show you what are these functions later. So let's say if I want to measure the period, okay, I will do the cursor. I just click here, x-axis. Then two cursor will come up, the C1 and C2. If I can use my mouse to click on C1 here from one point, another one to another point. Yeah? So this is the on the bottom here. This is the period. Okay, let me show you the annotation here. So on the bottom here, cursor 1 and cursor 2, the delta x is 1.012 millisecond. And then you calculate 1 over delta x also, just like the scope just now. Okay, the cursor function is just like the scope. So if I want to change to magnitude, let me X this guy here. If I change my cursor type to y-axis, the y-axis cursor will come up. You can measure the peak-to-peak voltage. This is the one peak here, and this is the other peak here. So on the cursor position, you can see there's a delta y. Delta y is the peak-to-peak voltage. Yeah. Okay. So this interface here is the reason why I chose this multisim, because the interface here is very nice, and also is very similar to an oscilloscope. Some other simulation tool, the scope interface is not so nice, but this is very close to the scope that I showed you just now. Okay, give me a while here. Okay, another thing that I want to show you is the DC shift. Under this component here, you can actually click on this AC voltage, and on here you can see there's a VA. Okay, this is the voltage peak to peak, and then this is the voltage offset. This is the DC voltage. Okay, let me show you the annotation here. So this is the amplitude, the peak to peak, and this is the output voltage here. The DC, this is the DC voltage. Currently is 0. The phase is 0, and the frequency is 1K. So if I change this offset here to, let's say, 1 volt, every time you make change, you have to do a run. When you do a run, so you can see that after you run, you stop. So you can see that your voltage has went up. I need to push down. Okay, your DC voltage has moved up. Okay, if I change this value here, I can change this value by clicking here or here. Okay, if I click here, my DC voltage, this is my peak to peak. Where is my DC voltage? Okay, DC voltage cannot be clicked here. So DC voltage, you have to click from this point here. I change my DC voltage to, let's say, 2 volts. Then every time I change, I need to run. So it will shift up again. Okay. So as I run, I can actually click the frequency here. I can slide the frequency 2K, 3K, 4, 5K, etc. You can see the frequency is increased. When the frequency is increased, you can actually use this zoom. You can actually zoom in and out. So you can see that it's not stable. So when it's not stable, means that you're not triggering properly. So you go to the graph mode here, click on the graph mode here, and you can see the normal trigger, single trigger. You just click to auto trigger, and you can see it's stabilized already. Yeah? Okay, so the voltage level, you change, let's say, to 2.5 volts. Okay, it's stable already. It will trigger at this point here, 2.5 volts. So this is the purpose of the triggering here. You don't have triggering, then it will be running everywhere. You do a auto, then you will actually set your voltage level to the right voltage trigger and you will steady. If my voltage here is, let's say, 4 volts, if I move it out here, then and I run it, okay, it's already running. Okay, I think you can because this software actually triggers automatically for you. Okay. Anyway, you need to trigger to see a nice steady waveform. So the DC, I've shown you the DC offset already. Let's see. All right, let's see. Okay, let me show you another one. Let me uh, remove this view and put schematic on it. I
Mr.
can
Paul,
create another schematic here.
Mr. Paul,
Yeah,
there's one question: how to create rectification circuit and the graph form by using Multisim tool? Full
yeah,
wave rectification circuit.
yeah. You can. You just need 4 diodes, and then after that you need a large waveform. And after that, you monitor. What you do is in your schematic, you can actually, okay, let me finish this just for a while, and then after that, I go to this question. So let me create another AC voltage here. Yeah, okay, another resistor here. What I'm doing here is a very simple circuit to demonstrate. You need to explore further if you're interested. Explore further, and and a lot of functions you can use here. Even though it's free, you can actually use this a lot of functions here. But as you go into expert level, you find that it's not enough. Then I guess you have to pay money for the advance. So let me change this to 1K. Okay, I put another probe here. So there are two probes. There are two channels already. So if I run this simulation, you have to go to the split mode. You can see there are two graphs here. So if I can change my this uh, degrees here, this is the phase. My phase information. Let me change my graph here. If I change my one of the phase here, I can shift the phase here to be uh, lagging or leading. Okay, so this is one of the demo. All right, so let's see. Let me open up the rectifier. Okay. All right. For this purpose, let me delete this guy. I saw the stop. Okay. A quick one. Let's do a rectifier. Let me keep this AC waveform. So, and I put it in diode here. Let's see. All right. This is probably the first time I'm doing this on the multisim. I can duplicate another one here. I can duplicate another one here. I can duplicate another one here. And I can join. Let's say this is the your voltage here. Actually, this is the uh, high voltage. High voltage will be 250, 230 volts RMS. It's about probably 400 volts peak to peak. The frequency is 230 hertz. Okay, then I'll join the wire. I think I need the a load here. Let's see whether it works or not. And I probably need a capacitor here. Let's see, and I'll just do connection. The AC will connect to this diode here, and it will go into this circuit here. It will come out to this circuit here. I do a return path to here. I can actually reverse this one here. And let me see, one goes here, and another one will go from here. See, this wave will go from, okay, let me try. If it works, then it's good. If it doesn't work, then we can, I'll get back to you another day. Try this. Looks very complicated. I'm not sure. Let's try. All right, do a simple one, and then let me measure the voltage here. All right, just cross your finger and see what happens. Oh, oh, here you go. Okay, not very nice. Okay, maybe just some circuit. So this is like a half wave rectification, but the other wave is not coming up. I think the circuit got some other issue. Let me change my value here to this higher value. Then it'll be nicer. And my DC here will be okay. Let me send out the right schematic for you, and then after that, you should be able to see the rectification. All right. Okay. So let's see. All right. Okay. Let me move on to the next demo. Any questions so far? Go to this exercise here. Okay, so let me get this out first. Let me clear this. Unfortunately, you have to click one by one to clear. I'm not sure how to do a quick clear. Okay, instead of a sine wave, you can also put in the square wave. For example, this is the clock. Okay, you put in the clock here. You put in the resistor here. You can make a turn. You can join the wire here. Join the wire here. And I can actually join another wire. So once you're done already, you just run the thing, and you can see that the square wave will come out. Nope, sorry, I got to put the voltage probe. I run, then the voltage will come out. So this is the square wave. All right. So like the normal scope also, you can use the function here. This is like a button. You can actually zoom everything at one time, zoom everything, but it's too complicated. You can also change the minimum and maximum. Let's say I change it to, let's say, 10 milliseconds. I can change this range to 10 milliseconds. Okay, and I change this range to, let's say, I see 5.5, okay. But I find it easier to use the mouse and just click. So this is, if you want to see everything, you just zoom all and everything will be shown. All right. So the next thing I want to show is the trigger function. Then after this, I think I'll just go to the closing theory and then we'll call this a day. Okay, let me do, let's try this. Let me put in a DC voltage here. Let me remove this guy. Let me put in a switch. Switch here. Try a switch here. Okay. I put the wire. Okay, so let me run this. So let me do the both view split. You see the previous chart here, don't worry. So when I run it, you see there's no trace here until I close the switch. When I close the switch, the voltage will go up. Open the switch, the voltage will be 0. I close the switch, it will be actually 12 volts. If I stop this here, do a graph, click on the graph, you zoom all. Okay, you can see these are the transition. So if I actually use a single trigger, make sure that my trigger level is correct. If I trigger at, let's say, 5 volts, I click at 5 volts, then I use single trigger. Okay. So when I run the simulation, let me open up this one first. Let me open up this one first. And when I run the simulation, nothing will happen. Okay. Actually, it's waiting. Let me look at the annotation here. Under you can see it's waiting for the trigger. That means it's waiting for the signal to trigger and show to you. So if I click in this on button or the close the switch here, okay, it will trigger. This is the rising edge that it triggered, and after the trigger, it will show you it's triggered. Then you can actually zoom in and zoom out to show the waveform. I need to stop this one first. You do a zoom all, so you can see the waveform over here. Okay, this is where we trigger it. We captured the signal by giving instruction to the scope that I want to do a single trigger. Once you see the signal rising up, okay, rising edge up, please stop the scope and let me check. This is what you're telling the scope. So if my level is not correct here, let's say I put it to maybe 15 volts. It is 15 volts is out of the signal here. And if I run this, it is waiting. And then when I close the switch, it didn't trigger. It's still waiting. It's still waiting because the trigger level too high. You need to trigger level lower. So what you do is if you trigger this level to about maybe 10 volts, it will trigger. You run it, and then it's waiting. And when you close the switch, it will trigger at this point, exactly at 10 volts. Okay. So you can use this trigger function to capture a single event, which is important for you, which is only come in only once. It doesn't come in any time anymore. So under the, you can actually use the falling edge. When I click falling edge, if I run this guy here, okay, I wait for trigger, single trigger, and I run Okay, it's waiting for trigger. When I click this one, the falling edge. Okay, I think I got it wrong. Single trigger, 10 volts. I zoom. Okay, if I run this guy here, sorry, I need to on this feature. You run this guy here, when I click this one, so that should be triggered. Give me a while, sorry about this. Single trigger, falling edge, 10 volts. Okay. Falling edge. Okay, I'm ready. When you run it, it is waiting, and when you stop it, okay, that means my trigger level not correct. Let's put it to, let's see, okay, 5 volts. When I run it, I'll just, it's waiting, I'll just close, open. You can see that you trigger at 5 volts. Close, trigger, it will always trigger at this, triggered. So if I can reset this again, okay, if I turn it on here, I close and open the switch, okay, it will trigger here. Once you're done already, you close this one and then you open up the waveform. You can see this is the falling edge. You trigger at the falling edge. Alright, so you can actually use this one to trigger rising edge, falling edge, and the level is important. If you don't trigger the right level, you will not see on the graph here. Okay, so single trigger is to trigger a single event. Automatic, if let's say the waveform is continuously there, then auto waveform will be very ideal for this triggering. I think that's all for the demo. Any questions so far? We have a lot of information here. May I, okay, there's a question here. May I know how to connect to probe? My graph can't show. Okay, so under the probe here, on the schematic, you use a voltage probe here, and then you move your mouse to the point. When it actually clicks, then you release. So this is the voltage point. Okay, you remove this one, and when you run it, the graph will be running. Yeah, the graph will be running. Okay, I hope that answers your question. Yeah. Okay, the other question is, if I'm not mistaken, cannot copy the circuit, but you can print screen and paste in Word. Yeah, you unfortunately you cannot copy the circuit. You need to print screen. Okay. So okay, let me just do a closing for this theory, and then we are done for the day. Yeah? So just now I show you the multisim here. This is a very useful tool for simple demonstration to the students. You can put a circuit here, resistor, a series resistor, and you can actually simulate and monitor the voltage or current or information that you want. And you can put a circuit like a LED or buzzer or lamp, and then it will light up or turn off. The graphic will tell you whether it's on or off. Okay, so now the function of the scope, just now I already showed you the demo from the scope. Let me remove the annotation here. Okay, this is the voltage or the horizontal, the time scale. This is the voltage scale. You can change the two knobs here to shift the waveform up or to magnify the waveform. This is a trigger. To do single trigger or auto trigger, you use this trigger. These are the measurements for you to measure like frequency, period, and cursor for you to move and measure specific time points in your graph. This is for compensation. And I show you this now, the demo. So under here, you will see that this one will magnify the voltage or reduce the scale. This one will shift it up or down. The horizontal scale will shift it left or right, or can zoom in or zoom out. Yeah. So this triggering here, you can do single trigger or auto trigger. If let's say you only capture the a single event, so you need to do a single trigger. You need to set the level correctly. You need to set the voltage rising edge or falling edge correctly. So this is important. This is important also. So trigger type, trigger condition, and also the trigger level is important. And the cursor, you can use the cursor to actually measure the period or the frequency or the voltage. This is it will show you on the graph here on the bottom. You see the measurement delta x and 1 over delta x. All right. So I think this is the end of the presentation. A lot. Any questions so far?
Teachers have any questions?
Just now, okay. Right. Very tiring, huh?
There's a lot of new things I also learned today.
Yeah. So the important thing is you need to start the tool early. If you start the tool too late, and there are a lot of things that you will not be able to catch up. So immediately after this class, just register in the Multisim, and you can actually simulate many circuits for your class under electronics. You can do a resistor network, the LED circuit, the lamp circuit, the buzzer circuit, plus other circuits. You can actually try it out yourself. Transistor circuit, MOSFET circuit, other stuff you have to explore. Okay, if let's say you need a certain circuit, you can actually search. A lot of people have already done some circuit. You just look for their circuit and run. I think that will be sufficient also. So on the rectifier one, I'll get back to you on the rectifier. Then you can try out the circuit on your own. All right.
Okay.
Wow.
Thank you, Mr. Pham.
Yeah. I hope I don't confuse anyone. But anyway, the exercise is important.
Hope all teachers can answer the assignments and also the quizzes that being prepared in the Google Classroom. Okay.
If you have any question, you just put a post in the Google Classroom. Then I'll reply to you as soon as I can.
Okay, Mr. Pham. So all the teachers can contact each other and also with Mr. Pham by using the Google Classroom, right, Mr. Pham?
Yeah, what?
The teachers can contact you to ask regarding oscilloscope by using the Google Classroom.
Yeah. You will go to my email. Then from the email, I can reply immediately. If they need help, then we can actually go online session. Or let's say after this class, you find that you have other questions. Maybe you can contact Penang Science Cluster. Maybe for other projects, maybe you want to come up with the circuit board to generate the sine wave or square wave using Arduino. Or maybe you want to make your own oscilloscope using the Arduino. Or maybe there are many things that you want to try out, but maybe you don't have the time. Maybe you can contact Penang Science Cluster, and then they would find people to look into it.
I will share the link who you need to contact, which who is Kak Amira, Miss Amira. I will share her contact details later.
Yeah. Sure.
Okay. Thank you, Mr. Pham.
All right. Okay. No question. I just say bye-bye.
Okay. Thank you.
Right. Okay.
Okay.
Bye-bye.
Bye-bye. See you soon.
See you.
Okay, as for teachers, please don't leave the meeting yet because I will share with you QR code for the LDP marks.